Okay, so I messed up the video and I have to add this on. Um, so we finished with, I gave you something different. I don't even remember. And the idea is this was a function. You're asked to find the inverse, and let's just go over it again. You can switch the x and the y. And so once again, put x over 1, cross multiply. Okay, and the idea is move the y's to the left, the x's to the right. So you have xy minus 3y equals negative 5x minus 1. Pull out the y, factor out the y. So we have negative 5x minus 1. And y equals negative 5x minus 1 over x minus 3. So this is the function. This is the inverse. We're going to be studying rational functions in a bit. The other interesting thing about the inverses, let me get a new pen, is that it turns out that if we see here that we said that the domain here was all x's, and x can't be negative 5, right? Because we can't have the 0 in the denominator. What we're going to learn is that the domain of the function is actually the range of the inverse. We're going to see that. And also, we're going to see that the range, this fraction can never be 3. So this can never be 3. And it turns out that we can see that this domain cannot be 3. And so IB is going to ask you weird questions. They're going to say, the domain, they're going to use some crazy function. They're like, the domain if the function is 3, is negative 5, what's the range of the inverse? So you have to be like, some kids will freak out. Like, I don't know how to find the inverse of that. And you go, no. The domain of the function is the range of the inverse. And the range of the function is the domain of the inverse. So that's a little thing. We'll talk about the domain of the function is the range of the inverse. Fun fact, and vice versa. The range of the function is the domain of the inverse. And we'll see that when we do. Good. Now, what else was in the video? I saw graphs, the inverses. And not just the rest of the unit is kind of small. The idea. Sorry, I'm mining the pens. One thing I want to talk about. How can we graph the inverse? Well, sorry. Let me fix the computer. So do we have a quick way of graphing the inverse? The idea is we're going to use this idea that if a point in the function is graphing the inverse. And the idea is if x has the function xy, then the inverse has function yx. And so let's start off with the line. Let's pick a line. F of x equals 2x plus 4. And so you say, okay, I can graph that. That's easy. Now, you can graph that. Now, the easiest way to graph any line is by intercepts. You can say, you know what? When x is 0, y is 4. And when y is 0, or f of x equals 0, x equals negative 2. Easy, right? So you plot the 2 points. You're like, this is 0, 4, and 0, negative 2, And this is our line. Y equals 2x plus 4. The question is, how do we sketch the inverse? How do we sketch the inverse? And it's kind of cool because you know what? If we know that 0, 4 is a point, that means that 4, 0 is part of the inverse. And if we know that negative 2, 0 is a point on the function, we know that 0, negative 2 is a point on the inverse. And so we can be like, okay, so let's see, we have 0, negative 2, and we have 4, 0. And just a quick way to get some points in your inverse function. If for some reason you can't figure out how to, if you can't figure out how to, find the inverse, you can still find some points. And then you'll note, once again, you'll notice, so it looks like the line passes through 2 points. And then you'll also notice, you'll say, hey, Mr. Adler, these 2 lines, it's like they're reflected through the line y equals x. And you can kind of do that yourself. Right here, I drew the line y equals x, and lo and behold, this was the function. This is the inverse, and they're reflections through the line y equals x. I'm just going to say, I think we're done. I just want to say something. You can plot the inverses on the same graph, but once you start getting to real world situations, don't do that. Let me just talk about this for a second. Without any context, like these are just x. These are x values 1, 2, 3, 4, 5. These are y values 1, 2, 3, 4, 5. Okay, and so this y and this x still go along that scale. But the idea is that the problem is that these might be real world situations. Like this might be time and height. And so, once again, you're not being tested. I'm trying to make a point. If this is the function, let's say it's h of t. H of t equals, 200 minus t squared. Right? That means this is time and this is height. But if I took the inverse, that means I'm switching the axis. This is time and this is height. And so the problem with putting the function and the inverse on the same graph is that you don't have the same axis anymore, and it runs into little problems. You're never going to see this because of that, but I'm just telling you, you can graph a function and its inverse on the same graph, but once you start talking about real world problems, you need to separate the 2 graphs, what they look like. We studied parabolas and its inverse. That was the first thing we talked about. It looks like this, and the function looks like that. But you can't, let's see, no. The inverse, as height increases, yeah. So the function, the inverse kind of looks like this. But you can't put it on the same graph because, once again, you switch the axis. That's the whole point of the inverse function. This is now the x-axis. This is now the y-axis. I'm done. We're done with the unit.